Theorem 10.9. Theorem 10.9 states that if and only if a radius of a circle ends at a point of tangency for a tangent line, then the two lines are perpendicular. So basically what this is saying, it's saying that if you've got a radius that ends at a point of tangency, then is perpendicular to the tangent line. So like in this case, r is both the radius and it ends at the point of tangency, which is t, and so it is perpendicular to L. So I'm going to read my paragraph proof word for word, and then I'll explain it to you in more basic terms. With two lines, one of them will be perpendicular to the other one at one particular angle and at no other angle because of the definition of perpendicular lines. So if r is not perpendicular to L, then line N, which intersects L at A, which technically is any point but T, will have to be perpendicular because of the previous statement. Since N and L are perpendicular, then angle CAT will be 90 degrees and angle CTA will not be 90 degrees. CAT, lines N, R, and L, form a right triangle. Since angle CAT equals 90 degrees, R will be a hypotenuse that is opposite of a right angle because of the definition of a right triangle. Therefore, N will be a leg in triangle CAT because it is adjacent to the right angle. R and D are both radiuses, and as such, they are equal to each other. Line D is a segment of a larger segment, N. D is smaller than N, so R is also smaller than N because of the transitive property. If R is smaller than N, then R cannot be the hypotenuse, and N with N being a leg of triangle CAT because of the definition of right triangles. Therefore, triangle CAT cannot have angle CAT be 90 degrees because it will not be a proper right triangle. So since angle CAT cannot be 90 degrees, N will not form a 90 degree angle with L, and won't be perpendicular to L either. Therefore, if N is not perpendicular to L, and N is basically any line aside from R, R will have to be perpendicular as one line and one line only, the one that intersects 90 degrees, will be perpendicular. So, one line and one line only will be perpendicular to L. So, I'm going to prove that R has to be perpendicular because none of the other lines can be perpendicular to L. And N is, I've given it a position in this picture here, but it is basically any it's any line aside from R that happens to intersect L and start at the center of the circle. So lines R, L, and N form a triangle, and if we assume that N is perpendicular to L, then it intersects a 90 degree angle, meaning that N will be the leg in this triangle, in this right triangle, and R will be the hypotenuse. But N is larger than R because it extends past the radius, so therefore it cannot be the leg with R being the hypotenuse, and so it cannot intersect L at a 90 degree angle, and meaning that N cannot be perpendicular to L, and R is perpendicular to L, because one line and one line only will be perpendicular.